Okay, welcome to the video for the second half of the key features of quadratic functions. This starts on page 6. Page 6 isn't really any notes or any work or problems to solve. This just shows you the different forms. So we have standard form, which we've already studied a lot and learned about these different uh, parts of a quadratic function. Um, Mostly we focused on A, B, and C. A being the leading coefficient, C and how that's the y-intercept. Uh, so things like that. Now we're going to take a closer look at what's called vertex form and intercept form. Now, the intercept form, what that is going to tell us, because if you remember when we had standard form, we could tell the y-intercept by looking at C. In intercept form, we are actually going to be getting the x-intercepts. If there are any. Remember, there's not always going to be x-intercepts. Usually we see two, but sometimes there's just one, and that's if the vertex is on the x-axis. But sometimes the parabola could be above or below the x-axis, and if it's below the x-axis and it's concave down, it'll never touch the x-axis. And same thing if it's above and it's concave up. So you'll see some of these examples later on in this unit. All right, so over on the next page, page 7, let's take a closer look. Remember, standard form, we've already studied this and we know a lot of this information. So the max or min, concavity, and the y-intercept. So if I'm looking at this, let me identify my parts. So I have an A. A is that leading coefficient, that's -2. B is the middle coefficient, and that's 7. And then C, which is going to be my y-intercept, is -1. So max or min, because A is -2, that means it's concave down. Well, actually, I'll go to that concavity in the middle there, down. And because it's concave down, that means I have a max. Max. My vertex is the highest point. And then the y-intercept involves this -1. Now remember, if we're talking about the y-intercept, this point here, the x value is always the same. It's 0. So the -1 is just our y value. Okay, vertex form. So y equals a, which you should be familiar with. We've already studied and learned about a. Now, here's where we have something new. X minus h plus k. You're probably wondering, what the heck are h and k? Why do we have all these letters? I thought this was math. Math is just numbers. H and k are going to be our vertex. Okay? So vertex is our turning point, our max, our min. We're also going to learn how A is not only telling us if it's a concavity, but it's our compression factor. And we'll see this more again later on when we talk about what's called transformations. Okay, so if I have a quadratic function already in vertex form, like these examples are, I know what my h and what my k are. So that means my vertex here. Notice up in the example or in the what the formula is supposed to look like, we have minus h. So because there's a negative there, that actually means the 2 is fine as it is, and the 1 is fine as it is, okay? However, when we get over to this example over here, we're going to see something a little bit different. And compression factor here, that's our A, is 3. Now, what does that mean? If you plugged this into your calculator and you looked at the graph, what you would see is the graph would all of a sudden become more narrow. It's like a bigger number there squeezes it together. Our parabola, narrow. So now with our vertex over in this next example, there is not a subtraction sign here. So we've got to take the opposite of that. So it's not 3, it's -3. That's our h. And then same thing with our k, because it should be plus k, but because we have a minus there, it's -4. And our compression factor is a 1/2. Now, what's going to happen when we put a fraction or a decimal as our leading coefficient? It's going to make it wider. Okay, so if a regular parabola looks like this, U-shaped, a more narrow parabola might look like this, almost like a V. And then a wider parabola is going to look like this. Okay? Yeah, I'm being specific and put my arrows there. So that's what we're talking about with the compression factor. Let's go ahead and take a look at intercept form, although the main focus of the rest of these notes are going to be on vertex form and how we get it in vertex form and things like that. So essentially, if we have intercept form, it's basically like factored form, okay? And notice we have subtraction signs here. Basically, what that's telling us is it's going to be opposite. I often tell students negative, another way to say negative or minus is opposite. Opposite the sign. So notice how I've got +1 and -3 here, okay? So when I look at them as x intercepts, the +1 becomes a negative, and the -3 becomes a positive. I hope that's not too confusing. And then this, don't worry, is not going to be as important as the vertex form. All right, and then you see the same example over here. Now again, our compression factor, there is no number in front here, so that means A is 1. So there is no compression. It's not getting wider or narrow. No compression. No comprende. However, in this one over here, the second example, we have a compression factor of 2, which means since the number is bigger than 1, it's going to make it narrow, more narrow. I always hated saying skinnier or wider. It's not skinny, it's just narrow, okay? It's making it more like a V. Okay, let's go on to the next page. I'm going to pause the recording for just a second. I'll be right back. Okay, so now over on the next page, page 8, we're going to do some converting here. We're going to use what we know about these different forms to convert from standard to vertex form. Remember what vertex form looks like. We're talking about y equals a. Actually, you know what? Let's do this. Y equals ax squared. Let me do that. So we're going to convert from this form, standard form, plus bx plus c, to this form, y equals a. What am I thinking here? X minus, I had to think about it for a second. The h and k always kind of gave me a little bit of trouble when I was learning about quadratics. So it might do the same for you, but that's okay. We get better by practicing. So we're going to convert it from this form to this. Now what's nice is a stays the same, okay? So there is no number in front of the x squared. So I know my a already is 1. B is this middle term, that's -2. and C is -3. I'm not really going to need C in this, okay? So the first step here is to find the vertex. Now, I can use the axis of symmetry. Remember, there's a formula here, -b over 2a. Well, I have my a and I have my b. If b is -2, that means -b is +2. And then since a is 1, so we have x equals 1 is our axis of symmetry. Now, I plug in that 1 into my formula, my x squared minus 2x. I'm using the original formula here. And I'm going to substitute 1 in for x. So 1 squared minus 2 times 1. And I know some of you are probably getting a headache and saying, oh my God, I'm not going to remember this. Relax. It'll be okay. And that is -4. So my vertex is 1, -4. Now, if you prefer, you could actually plug this formula into your graphing calculator by going to y equals. So I go to y equals, I type in that formula, second graph, which gives me the table, and I look for the turning point. Now, it's not always going to be this easy, but here it is, 1, -4. You should be able to see how it goes, -3, -3, 0, 0, 5, 5. So you can see that middle point is 1, -3. Let me check on my time here. Hold on. Okay, so now I'm going to fill in my parts. So remember, it's A, so A is 1. X minus H, well, my H and K, so minus 1. And then my K is -4. Now, really, the way I want to write this is y equals, I don't need to put a 1 in front of this, x minus 1 squared, and then not plus -4. I'm just going to put -4, okay? It's okay if you had the 1 in front, and it's okay if you did have plus -4, but we don't usually see it that way. Okay, I want you to try the next one on your own. I'm going to pause the recording. When I come back, you should pause the video. When you come back, you should see the answers and we'll talk about it. Okay, so we are back. And as you can see, I worked this one out. First thing I always do when I'm working with quadratics is identify my A, B, and C. In this particular exercise, we're not really doing anything with C, our y-intercept. We don't really need it for this. But I always just identify it because. So I used my formula for finding the axis of symmetry, x equals -b over 2a. I substituted my values in. So opposite of b, or -b, so b is 4, it's -4, over 2 times a, which is -1. So -4 over -2 is +2, negative divided by a negative. So x equals 2, and then I substituted that 2 in to my original quadratic. Notice I used parentheses here because I do want, that is very important. If you don't, you might actually get, well, actually in this case, yeah, it would give you the wrong answer. I was going to say we ended up with 0, but we would have, if you didn't use parentheses correctly, you might end up with something different. But y ends up being 0. So our vertex is 2, 0. You could have used your graphing calculator to find that point in the table or on the graph. That's our H and K. So I use my vertex form, substitute A, H, and K in, and it can look like this: -1 parentheses x minus 2 squared plus 0. But we don't really need plus 0 at the end. So the other option is y equals negative parentheses x minus 2 squared. Okay?